Before we launch, here's the scoop. This is a what-if adventure starring 6 superstar elements: tungsten, titanium, bismuth, quartz, aluminum, and silicon. Let's see what science and imagination can create. Welcome, space explorers. Buckle up. We're diving into material science, where atoms dance and elements become heroes. What makes spaceships zoom and survive? Not just rocket fuel, it's the super-powered stuff they're built from. On Earth, a secret squad of elements teams up to build machines so cool, even aliens would want a selfie. Imagine a rocket blasting to Mars, no snack breaks needed. That's the magic of the right materials. To do that, we need materials that are super strong, able to take a cosmic punch. On super light so rockets don't get weighed down, think feather on a diet, and super special with secret skills, like a spy in a lab coat. Meet our all-star squad, 6 elements, each ready to save the galaxy one spaceship at a time. Roll call: tungsten, titanium, bismuth, quartz, aluminum, and silicon, the avengers of the periodic table. No capes needed. These elements have real science powers. Together, they build things that are truly out of this world, literally. Ready to meet the team? Let's jump in, cannonball style. First up, tungsten, the heavyweight champ of the element world. Tungsten is denser than lead. Imagine a sumo wrestler made of metal. It's super tough, with the highest melting point of any metal, hotter than your pizza oven on overdrive. Tungsten can handle the heat of space and keep its cool under pressure. Fun fact, old school light bulbs, their glowing wires were pure tungsten. Next, titanium, the superhero with a secret identity. Strong as steel, but half the weight. Imagine carrying a steel beam. Now cut that weight in half. That's titanium power. Light as a feather, strong as a tank. Titanium is the best of both worlds, and it doesn't rust. Titanium is like a raincoat for your gadgets, built to last. Now make some noise for bismuth. Part metal, part rainbow, all magic. Wait till you see what it can do. Meet bismuth. Part metal, part rainbow, all magic. Its wild crystals look like a unicorn built a staircase. Heavy, but melts so easily you could almost do it over a campfire. Those crystals? Rainbow stairs for ants. Tiny, geometric, and always ready to party. Bismuth never has a dull day. It's heavy but melts faster than ice cream in July. That makes it perfect for jobs where metal needs to flow into tiny spaces. And bismuth is non-toxic. Unlike some heavy metals, it's safe enough for medicine, science, and sparkle, all in one. Check out those crystals, nature's pixel art. Each one is a tiny masterpiece, showing off bismuth's love for color and geometry. Fun fact, bismuth is in some stomach medicines. Next time your tummy feels better, thank this rainbow metal. Doctor by day, disco ball by night. Bismuth helps people and dazzles scientists at the same time. Bismuth, saving stomachs, stealing spotlights. Proof that science can be both useful and fabulous. Next up, quartz, not a metal, but a rock star. Made of silicon and oxygen, it's one of Earth's hardest, most common minerals. Quartz is silicon and oxygen, science's dream team. It's in sand, computer chips, and watches. Talk about versatile, super hard, and super useful. Thanks to quartz, we have sand castles, glass, and electronics. The unsung hero of the element squad. Squeeze quartz and you get a spark. Piezoelectricity. Quartz turns pressure into electricity. Shocking, right? Now, aluminum, the shiny superhero. Light, fast, and everywhere. From kitchen foil to rocket ships, aluminum is always ready for action. You know it from foil. Super light, super bright, and perfect for leftovers or spaceships. Foil your enemies, indeed. Featherweight champ, light, fast, and ready to roll. Aluminum is the go-to for anything strong but not heavy. Airplanes love aluminum, light, strong, and always runway ready. It's the secret behind flight and speed. Superhero suit, anyone? Aluminum's got you covered. Shiny, protective, and always in style. Last up, silicon, the brainiac. Silicon is the backbone of modern tech, running everything from computers to solar panels. Silicon is everywhere in Earth's crust, Earth's favorite chip. It's why we have smartphones, laptops, and all things digital. It's in computer chips and solar panels. Tech VIP. Silicon controls electricity, making it the ultimate traffic cop for electrons. Silicon controls electricity like a traffic cop for electrons. Without it, our gadgets would be lost in the dark ages. Shocking talent, right? Give it up for our superstar elements, each one with a special power, ready to take on the universe. You can't just toss all the elements in a pot and hope for spaceship magic. This isn't fondue night. Each one needs special care, or you'll get a cosmic mess. Instead of melting everything, we outsmart the heat. Think mad scientist, lots of goggles, no bubbling goo. Here's the trick. We turn our superstar elements into powder, super fine, like flour, but way cooler. It's the wildest recipe in the galaxy. Forget cake flour. This is spaceship flour. Powder so fine, it could make a cloud sneeze. Each grain is a tiny superhero. We mix them, tungsten, titanium, eLeMeNTS, silicon, and more, like Avengers in dust form. This is powder metallurgy. It's like building sandcastles, but with element confetti and science instead of a bucket. First step, gather your metals. Avengers, assemble. Each brings a superpower. Tungsten, the heavyweight champ, tough as nails and twice as dense. Titanium, strong, stylish, and light on its feet. The secret identity hero, aluminum, the featherweight ninja, fast and shiny, always ready for action. Silicon, the brainiac, running the show behind the scenes. We grind them all down, superheroes, until they're glitter-sized. Justice League, meet confetti. Then we add quartz powder. Every recipe needs sparkle. It's the secret for strength and shine. Each spec is mighty. Fancy confetti with a mission. Together, they're ready to build something out of this world. This powder mix is our secret base. No capes, just science. It's the foundation for every spaceship part. But how do we turn this powder into something solid? Spoiler, not with a glue stick or duct tape. You can't just squish it together unless you want a pile of dust bunnies. We need a smarter way. Enter binder jetting. It's like 3D printing, but with a secret handshake and a dash of sci-fi. Instead of melted plastic, we use glue. Think decorating a cake, but the cake is metal powder. No plastic spaghetti, just precise drops of glue, landing exactly where we want. Pastry chef engineering. The machine spreads a super thin layer of powder, like fairy dust for engineers. Each layer starts something epic. Zoom in. It's a cosmic cookie recipe. Layer after layer, each thinner than paper. Sprinkle on more powder. This sugar can survive a rocket launch. Sweet science. Each layer is measured with ninja chef precision. That's how we get spaceship parts sharper than a laser. The result? Laser sharp spaceship parts, ready for action. No dull edges in this galaxy. The print head glides over, like your home printer, but way cooler and with a lot more science. No ink here, just tiny drops of glue, placed by a robot chef with perfect aim. The glue only lands where we want it. No mess, no fuss, just pure science magic. The glue soaks in, and the powder turns solid, like a magic trick, but with molecules. And guess what? The glue is actually one of our superstar elements. Science plot twist. We repeat this process, layer by layer, until we've built an astronaut cake. No candles, just engineering. The platform drops, the next layer begins. No elevator music, just the hum of science at work. More powder, more layers, sprinkles with science. Each one brings us closer to a finished part. The print head sprays, the layers stick, and we keep going. Repeat until awesome is achieved. Building a spaceship part, it's like baking a high-tech cake. Each layer printed, bismuth as the glue. 3D magic, ready for space. The printer spreads powder, then sprays bismuth, liquid metal glue. Layer by layer, your part grows. No candles, just science. Wild shapes? Easy. Bismuth glue follows the blueprint and holds it all together. Honeycomb beams? No problem. Bismuth glue keeps parts light and strong. Lattices, sci-fi shapes, old tools can't compete. Bismuth binds every layer, no hammers, just robot chefs. The computer guides, bismuth is the secret sauce. It's like building a sandcastle, one grain at a time, with bismuth magic glue. Here's the secret, bismuth is the ink that binds our powder, sprayed with perfect aim. The ink is bismuth. The rainbow rockstar returns as the binder. Drumroll, bismuth is our binder. Colorful, magical, and totally unexpected. Metal as glue? Yep. Bismuth syrup binds the powder, perfect for the job. No solid bismuth here. We make a bismuth smoothie for the printer to spray. The print head zooms, squirting bismuth juice where it's needed. Cake decorating, but with metal. Print head zips by, spraying bismuth, like a pancake artist for astronauts. And don't forget our superstar elements: tungsten, titanium, eLeMeNTS, silicon, quartz. No, not the watch, actual quartz. Liquid bismuth soaks in, dries, and holds everything together. Just sticky enough for science magic. We're making a Mars rocket bracket, no pressure. Bismuth is our superstar glue. The computer slices our design into thousands of layers, like a digital onion. Each layer gets a bismuth spray. The printer starts with the first layer, spreading super powder. Each layer is a step closer to Mars, with bismuth binding it tight. Printhead zips by, spraying bismuth, like a pancake artist flipping breakfast for astronauts. The powder gets sticky and clumps, instant teamwork. The rest stays loose, like sprinkles that missed the cupcake. Leftover powder just hangs out, waiting for its turn. Only bismuth-glued bits join the spaceship. The powder bed lowers. Think elevator for space dust. New layer, more bismuth glue. The printer sprays the next slice, gluing it to the first with bismuth. Pancake stack, science style. This goes on for hours or days. Good thing printers don't need coffee. Bismuth keeps gluing every layer. Bismuth goes exactly where we want, ninja precision. It coats the tough powder grains like space armor. Bismuth melts at a super low temperature. Tungsten and titanium? Fireproof. Bismuth is the marshmallow glue. During printing, everything stays cool, no melting yet. The oven comes later. For now, bismuth is a cool metallic glue. We're just making a green part, not eco, just unfinished. It's fragile, like a cookie before baking, held by bismuth super glue. Once printing is done, our part is ready for the next adventure, the science oven. For now, bismuth is the hero holding it together. Our spaceship part chills in its powdery sandbox, dreaming of Mars. Stay tuned for the transformation, brought to you by bismuth. Next up, turning this fragile green part into a space-ready superhero. It takes heat, science, and bismuth magic. It's a fragile, chalky version, like a cookie before baking, held by bismuth super glue. But soon, it'll be ready to blast off. Our rocket bracket is printed, but it's buried in powder, like treasure in a sandbox. Time to dig it out. Let's play archaeologist, brush and vacuum away the powder to reveal our fragile green part, held by bismuth super glue. Leftover powder? No waste here. We recycle it for the next print, smart and eco-friendly. Our bracket looks great, but it's as tough as cookie dough. One bump and it crumbles. You could squish it with a pinky. Not Mars ready yet. It's a doughy blob, full of potential, but not strong enough for space. All the ingredients are there, but it needs the science oven to get strong. Next, we turn this fragile part into a space superhero. Our green part is ready. Off to the sintering furnace. The furnace is like a science sauna. We tuck in our part, nice and gentle. Here's where the magic happens. Lab coats on. Let's heat things up. We turn up the heat. No marshmallows, just science. We heat just above bismuth's melting point. Hot for bismuth, but not a meltdown. Still way below tungsten's melting point. That stuff could survive a volcano. Titanium and quartz. Not melting today either. Only bismuth melts. The rest just chill. Bismuth does the limbo. As the furnace heats up, bismuth melts. Science magic time. Bismuth turns into silvery liquid, a superhero cape for powder. Because we printed it precisely, bismuth is everywhere it needs to be. It's like super hot, liquid metal glue. Elmer's, eat your heart out. Bismuth flows into every nook, filling gaps between the tough teammates. This is called infiltration. Awesome science, not sneaky at all. Liquid bismuth soaks through, filling every space. Like water in a sponge, infiltration does two things. Pulls particles closer, capillary action, like a paper towel slurping a spill. As particles snuggle up, the part shrinks and gets denser. Group hug for atoms. Second, bismuth fills all the gaps, making a continuous metal matrix. Ultimate team building. It's like mortar in a brick wall, but microscopic and super. We're not just mixing, we're making a metal matrix composite. Fancy words. Awesome results. Strong tungsten and titanium form a hard skeleton. No bones about it. Liquid bismuth locks everything in place like super glue, but shinier. Once bismuth's done, we let the furnace cool, like cookies on a tray. The furnace cools, drum roll, as it drops below 520 degrees Mars. Bismuth goes from silvery lava to solid metal, faster than you can say frozen pizza on Mars. No oven mitts needed. Our scientist checks the results. No burnt cookies, just science magic. Bismuth weaves through every nook like a superhero cape for our element squad, the only cape that never gets stuck in rocket engines. All our elements, tungsten, titanium, quartz, silicon, aluminum, are now locked together, tighter than a zero-gravity group selfie. The tough ones never melt, so the sprinkles stay safe. No element left behind. Careful heating and cooling means no crumbly cookies. Spaceships need strength. The result, a dense, tough part ready for action. It could survive a toddler's birthday party. Check out those thrusters, our brackets ready to blast off, not just hold up a science fair project. Ta-da! We've made a new material with all the best superpowers. It's the Science Avengers for spaceships. No spandex required. Smooth, shiny, and ready for its close-up. Eat your heart out, Hollywood. So, what did we make? Drum roll. No actual drums were harmed. Meet our rocket bracket, sleek, shiny, and liftoff ready. It's dense and tough, like a moon rock that lifts weights. If it had arms, it'd win every arm wrestling contest on Mars. Under the microscope, it's a science party. Spot tungsten the bodyguard, titanium flexing, quartz sparkling, and showing off its smart piezoelectric energy powers. It's not just a pretty face, and silicon probably updating its status. Titanium's showing off, as usual. Quartz is just here for the sparkle. These elements form the shiny skeleton. Heat resistance? This stuff laughs at lava lamps. Stiffness? Like a robot doing yoga. Flexible, but only in the right places. And between the tough guys, bismuth, the ultimate couch potato, glue, hugs the team together. Group hug. No glue sticks required. Tungsten and quartz, they laugh at heat like wearing a winter coat on the sun. They fight off wear and tear, perfect for engine parts and friction zones. Superheroes of not melting. Blue flames. Just another day at the office for these elements. Titanium powder keeps things light, lighter than your lunchbox. Aluminum's the speedster. Blink and you'll miss it. Together they're strong enough to arm wrestle a gorilla. But don't try that at home. Gorillas not included. Bismuth isn't just glue. It's a secret agent. It blocks radiation, giving our part a superhero shield. Move over, lead. Bismuth's got this and it's way more fabulous. Melting process, more like mission protection. Space radiation? No problem. Our material's got superpowers. It's a space-age Swiss Army knife. Strong, smart, and light as a feather in zero gravity. Warning, not an actual knife. Golden spheres, metallic bubbles. This is what happens when science and style collide. Imagine building Mars spaceship parts with this, out of this world. 3D print trusses, engine mounts, even Martian mansions. Martian real estate agents are standing by. Print wild shapes, strength only where needed. That saves weight so your rocket can carry more snacks to Mars. Priorities, right? Cheaper, easier missions, space. Piggy banks rejoice. This is a game changer for space travel. Houston, we have a solution, and maybe a coupon code. Our rocket is ready for takeoff. Next stop, the stars. We're building materials atom by atom. Science, jokes, and a sprinkle of awesome. The future of space is here. And it's got better puns.